When you saw two terms in the past, we would always ask the question, when we saw something like that last chapter, we'd ask the question, is the x squared a perfect square? Is the 9 a perfect square? And is this a subtraction symbol? Remember we'd ask those three questions? And if it was yes to all three of them, we were able to factor it real fast. Remember that? You get x plus 3x. Good. And did it matter the order in which you wrote that out, plus or minus? No, it doesn't matter at all. Okay. What happens that's a little bit different now for today is we're talking about cubes. We're talking about x cubed plus 27. Instead of asking if it's a perfect square, you're asking to see if it's a perfect cube root. Now, you could figure out cube roots on your calculators by taking the x root. I think that's which button that is. If you go to your calculator and you hit the math, you'll see that there's a cube root right away. You can take a cube root of any of the numbers just to check and see if it's a perfect cube to start with. So what happens is that there's these special patterns that occur with cubes when you're factoring cubes, sums or differences. In our example here, 27. You guys know what the cube root of 27 is? It's 3. Okay. So when you have sum of cubes, when you go to factor them, you basically have these two patterns to look at. They're very similar. In this example, since it's a plus, we'd have x plus 3. And then on the inside, you have x squared and a 9. All you have to do is you square them for the outer parts. And then the middle is just 3x. You multiply the two terms together. You multiply the cube root of x cubed and the cube root of 27 in the filling in. Yes, sir?
Oh, never mind. So why is it a minus 3x?
What's that?
When you said you multiply the 3 and the x,
Yeah.
take the middle, why would it be negative 3 times?
If you FOILed all that out, you want to be able to get rid of a middle term. And if you start FOILing that, you will find out that you get rid of a middle term that way.
Can you do that one more time?
I'm going to. All right. When you look at this, if you FOILed all this through, you'd wind up with x cubed minus 3x squared plus 27. And then you have plus 3x squared minus 9x plus 27. Multiply that out. Why did I multiply 27 3 times? Sorry, this is just 9x. What's happening here is that this term gets eliminated and this term gets eliminated by having that alternate sign in the middle. And it works the same way with the subtraction one. So what happens here, again, if you have x cubed, we'll say it's 64 this time. 64, I think, is 4. 4 times 4 times 4.
Wait, how do you find that? Or you just use your calculator?
Yeah. I'm just using perfect cubes that are that I know off the top of my head. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. I'm just using those as quick patterns. If you're not sure if it's a perfect cube, just use your calculator and it'll take the cube root for you. So again, when I do these patterns, if this one is a plus sign, I know I take the cube root of both of them. The inside terms will be these values squared, to be x squared on the end and 16 on the other end. And the middle term would just be the 4 times the x with a subtraction symbol. Okay? And then we do the opposite of this stuff, opposite of the, we have x cubed minus 125. I believe that's 5. Yeah.
You go back to the other one.
Yeah.
So do you leave it like that, or do you multiply everything out?
Yeah, what you're doing is you're factoring it. That's how you factor it. Yeah, that's how it's factored. So when it's a difference of perfect cubes, the pattern just changes that the first one is your perfect, or your cube root again. And now the interior terms are both going to be plus. Okay? So it winds up being x squared, 25, and a 5x in the middle. All right?
How do you know when it's plus or minus?
That's it's the pattern you're going to have to memorize. There's no rhyme or reason. What happens here is if you remember that if you're looking at a sum of cubes, the first one is going to be positive. If it's a difference, it's a negative. And then it's just a matter of the next term will always be the opposite sign. Then the last term is always positive. So if you look at, if it's a positive start, I know it's going to be positive here.
So negative.
Then it's going to be a negative, and then a positive. If it's a negative start, it'll be negative here. Then it's a see how it's the opposite then, and it's always positive. That's the easiest way to do it. You keep the sign that you're given as your first term. The next time you need to put a plus or a minus sign would just be the opposite of it, and the last term is always positive. It's kind of the best way that I can think of. All right. So now you'll have to start seeing some stuff like this. Once again, it's not going to be so scary, but we're starting to build into larger factoring of polynomials. Okay. Let's look at some. What's that? It's pretty scary? Yeah, well,
Yeah.
we'll be okay. We'll get through this. We just did that one. Excuse me. Take a look at this. (16x to the 5th minus 250x squared). That's pretty ugly. Now, what's your first rule of factoring? GCF. Is there a GCF with 16 and a 250? There's 2, think bigger. All right, so you have a u squared. Does 4 go into each of them?
No.
Okay. So if I factor out a 2u squared, then I'm left with what on the inside?
8u to the third.
Now, that's 2 terms, right? And they're ugly 2 terms, but are they both perfect cubes? They are. 8's a perfect cube. 125 is a perfect cube. So you can break this down further to continue factoring. As you do that, you bring the 2u along for the ride, 2u squared. What's the cube root of 8u cubed? Bless you. 2u. Remember, we're starting with a negative symbol here, so we keep the negative symbol. Cube root of 125? 5. Now, on the interior pattern, remember, it's going to be the 2u squared. Now, it's the whole thing squared, so the quantity 2u squared is going to be what? 4u squared. Yes, sir?
I don't know, just kind of looking at it. Why didn't we have to cube root 25?
That's the pattern. Right here, we have, these are both perfect cubes. So when you do your perfect cubes, you take the cube root of this term, and it goes here. You take the cube root of this term, and it goes here.
Oh, yeah.
All right. Yes, sir?
Can you always do it with the perfect cube then?
Yeah.
So, like, you can't do it with just a random number?
No. So you get 4u squared. What's 2 times 5? Okay. Now, is that going to be a subtraction of 10u or a minus, or excuse me, a plus 10u?
Why is it close?
Remember the pattern. If it starts as subtraction, it goes subtraction plus plus. If it starts as a positive, it goes plus minus plus. Okay?
So there's got to be one square.
Yeah, there has to be one alternate sign because that allows you to drop out the terms. Yeah.
Why didn't you multiply by 5 here and then 1 by
Remember, that's the pattern. what you do is you take this one times this one to create your middle term. That's how we create our middle terms. Okay? You multiply the two together, the perfect cubes. Remember, the pattern, as we go through the pattern again, if it's a cubed plus b cubed, it's a plus b, a squared minus ab plus b squared. That's what it's always going to be. And if it's minus, you just change your sign. That's always, always, always the pattern. Which leads us to be able to group again with higher powered polynomials. Excuse me. So when we're grouping, remember when you're factoring by grouping, that's usually when you're starting out with 4 terms. In this case, again, I have x cubed minus 2x squared minus 9x plus 18. And I'm going to factor that by grouping. One suggestion, one dead giveaway that you're going to be factoring by grouping is whenever you see 4 terms. That's usually the only way to go. When you factor by grouping, you're getting the GCFs. What's the GCF of that?
X squared.
X squared. So if I factor out an x squared, I'm left with x minus 2. Whenever your third term is negative, do the same change opposite so you don't forget it. And what's the GCF of a 9 and an 18?
A 9.
The 9. But remember, you want it to bring out the negative, so you bring out the negative 9. And you're left with x minus 2. Are those two things in parentheses the same thing?
Yeah.
All right, write it down. And what are you left with? X squared minus 9. Hey, wait a second. That's a difference of squares, isn't it? Is x squared a perfect square? Is 9 a perfect square? Is that a subtraction sign? So if I factor that completely, then I'm left with x minus 2, x minus 3, and x plus 3. And now I'm done. You just have to keep going. Remember, x squared minus 9, you can still factor it. If it's x squared plus 9, you can't. All right.
Wait, can't you do x squared plus 9 by just doing
No. You can't. If I'm just factoring, I cannot. I can solve it, yes, if there's an equal sign, because I can take it and work with imaginary numbers. But if I'm just factoring, no.
So if it was x squared plus 9, would that be kind of?
Yes, then I would stop. You factoring, so you can't factor no more. Give it all I can. All right. Take a look at. Let's try one like this. Again, very similar. It's 3 terms. 4x to the 6th minus 20x to the 4th plus 24x squared. If I'm going to factor that, what's the first thing I do? GCF. What's 4x squared? Okay. So then I have x to the 4th minus 20x squared plus 6, 5. Just check and see if you're paying attention. Good work. Am I done?
I would say.
Take a look at your degrees. See how your degrees are going down from 4 to then nothing? That means you can still factor it like you would if it was x squared minus 5x plus 6. Because that pattern works. So what times what is positive 6 that you add together to get negative 5?
2 and 3. -2, -3.
Negative 2, negative 3. So I have 4x squared minus 2, x squared minus 3. Can I factor that any further?
Yeah, you could square it. Square root it.
Do you see an equal sign?
No.
Can I do that?
No.
You're done. I cannot factor anything left over in those two parentheses parts because they're not difference of squares. It's just x squared minus 2 and x squared minus 3. If it was x squared minus 9, I could go further, but it's not. So I'm done. I'm factoring and factoring and factoring and factoring. Okay. What changes now? I'm solving. So when I'm done factoring, what do I have to do? Set it equal to 0. Very good. So again, we have 2x to the 5th plus 24x equals 14x cubed. What do you think your first step is going to be? On the other side? Okay. So we start moving some stuff around. So we have 2x to the 5th minus 14x cubed plus 24x is 0. Very good. Factor out a 2x. Everybody agree on that? That's your GCF. Then I have x to the 4th minus 7x squared plus 12. Are my powers decreasing in half each time? So what times what's positive 12, you add together to get negative 7.
4 and 3.
Negative 3, negative 4. Yeah, good. So we go again. 2x parentheses x squared minus 4, x squared minus 3. Can I factor that any further? I can. Where can I go? What does that become?
X squared plus 2 and x squared minus. Not x squared. X plus 2 x minus.
Good. So I have 2x, x plus 2, x minus 2, and x squared minus 3 equal to 0. Now, what was the degree of this problem to start with?
6. Wow.
Oh, the degree. What was the degree? 5. It was a 5th degree polynomial. The exponent was 5, right? How many possible zeros can I have then? 5 of them. All right. Let's see if we can figure this out then. What are your zeros? Do we have to write it out? Each one of these terms set equal to 0? Or can we look at it and say it? All right. What's your 0 here?
0.
Bless you. What's your 0 here? What's your 0 here? What's your 0 here?
Root 3.
Plus or minus the square root of 3. Add 3, take the square root. Bless you. Remember, anytime you take the square root over an equal sign, you have to do plus minus. People are still forgetting that on the test. Plus minus.
Yeah.
There are. 0, 2, negative 2, square root of 3, negative square root of 3. Okay? So that's how you figure out how many.
Wait, I thought you said there was 5 zeros.
There are. 0, negative 2, 2, square root of 3, negative square root of 3. There's still 5 of them. All right? There's still 5 of them. All right, try this one on your own. That's fine. That's fine. Remember, if you're going to, this is a great question here, guys. Do you have to, do you have to write this out as x plus 2, x minus 2, if you're solving for zeros? You don't. You really don't have to. If you get to x squared minus 4 and you're solving for zeros, you can just go ahead and do that. You know, just say plus or minus 2. It's okay. Same thing like the problem we had earlier. It was x squared minus 3. You couldn't factor that any further, so you had to write it as x, plus or minus square root of 3. When you're factoring these things down, you don't have to do that last step if it's a difference of squares. Okay, that's a great question. You really don't have to. So we had a third degree polynomial, and I had 3 zeros. Possibility of having 3 zeros. There, we get into more and more as we go. Let's see, we just did that one. Oh. Do those, please. Even.
Oh, yes.
What's that?
You should have just said yes.
Yes. All right, it didn't. All right. Instead of just giving you guys the sections that say, oh, let's solve this by grouping. Oh, let's solve this by GCF. Oh, let's solve this by sum of cubes, all that kind of junk. I gave you the section that said, on your own, figure out which one to use. Who? Oh, wait, what are the two different? What are the yeah, I give it a look. Okay, wait. I can see I can see that one better. Oh, wait.